In example 7, we're going to be looking at an application of adding and subtracting radicals. And so we've got a couple of radicals, a rectangle, so let's read it. It says the length and width of a rectangle is represented by the expressions 2 square root of 405 and 9 square root of 48. Write an expression to represent the perimeter of the rectangle in simplest radical form. So I like to draw pictures for these application problems if I can. It's helpful. So I'll make the length 2 square root of 405 and the width 9 root of 48. Okay. And I need a formula. The perimeter of a rectangle is going to be equal to 2 times the length plus the width. So in this case, 2 times the length, which is 2 root 405, plus the width, 9 root 48. Okay, I'm going to go after that 2 root 405 first. I'm going to simplify that one first. Now 405 is a big number. It's not on my list. I can check that by just going over to Desmos and taking the square root of 405. It's a decimal. But 405 divided by 2 is 202.5. So we'll start there on the list. That's actually higher than the 144 that I have as my highest square number. So I'm going to use 13 and 14 squared. 14 squared is 196. So I'm going to see, is 405 divisible by 196? And it's not. 13 squared is 169, and that also doesn't work. And I can keep going down the list until I eventually get to 81, and 81 does work. So I can rewrite the square root of 405 as 2 square root of 81 times 5. And the square root of 81 is 9, so it would be 2 times 9 times the square root of 5 for just a total of 18 square root of 5. So that's going to be our length. Okay, now onto our width. We have 9 square root of 48, and just like 405, I put that into my calculator. It does not work as a perfect square. It's not on my list. But 16 is a factor of 48, and it is on my list. So I can rewrite this as 16 times 3. So 9 times the square root of 48 is the same as 9 times the square root of 16 times 3. The square root of 16 is 4, and the root 3 is going to stay underneath the square root sign. So this will equal 36 square root of 3, and that's the width. Now I would love this to work out where they were both square roots of 5 or square roots of 3, but that's not the case. So I'm just going to come back up to my original 2 times 18 square root of 5 plus 36 square root of 3, and just multiply these by 2. So 2 times 18 is 36, 36 square root of 5, and plus 36 times 2 is 72 square root of 3, and that is going to be our final perimeter. So again, this is an application problem, so a picture was helpful, a formula was helpful, and if there are any questions, please let me know. Otherwise, here is your opportunity to try it on the perimeter of the triangle that you see below in simplest radical form. If you guys have any questions, please let me know. Otherwise, we'll talk in class.